Right, we're just going to start off looking at your basic properties of your magnet, right? So each magnet will go. It's going to have a north side, so north, and it's going to have a south end. Right, in between, so going between north and south, so it'd be like that, going between north and south, you have the magnet's magnetic field, right? And the magnetic field goes and spreads out from each end of the magnet. So, you're going to have lines of magnetism spreading out from each end, right? Until you're going to go and get lines of magnetism going between the north and the south. If you go and look at this, this shows where the magnet's magnetic field is. The areas where those lines of magnetism are more dense, so more close together, so at either end, that goes and that shows the region of highest magnetic strength. So that's where the magnet is stronger. So the magnet is considerably stronger at the ends than in the middle. Right, one easy way that we can go and show where the magnetic field is if we go and put a magnet under some paper, if we gently go and just sprinkle our filings onto it, we can go and start to see where those lines of magnetism are. So you can see at either end we go and we've got strong magnetic fields because the lines are close together. You can see how those lines of magnetism are spreading out from either end, and you can see how they're going and they're curving round, going from north to south. So we can go then and see how we look at two magnets together, and we can look at how different magnetic fields go and interact with each other. So if we start off, right, magnets are a bit like thinking about chargers. Or opposites attract, likes go and repel. Right? So if we went and put two likes going towards each other, we should see that the magnetic fields from either side kind of like force each other away. So we should go and see a void in the magnetic field in the middle between those two similar ends. So we go, we put on our iron filings, so we can see there, that'll be one end of the magnet, that'll be the other end, but you can see in between where they are, there is no lines of magnetism. Right? That's because you've got two similar ends facing towards each other. If we went and turned that round, so you now had a north facing a south. So if we go, now we've got north facing a south, so they're attracting each other. Hopefully, we should go and see that we should have a relatively dense amount of lines of magnetism going in between the two magnets this time. So this time, because you've got a north facing the south, So there you can see, in between those two magnets, you've got lots of lines of magnetism that you can see by these, the dense amount of iron that's been attracted. So that is our basic overview about magnetic fields. If we wanted to go and just draw these, so if it's north facing the south, you'd go going to look like this, so you'd have strong lines of magnetism going in between the two. If we went and had a like facing a like, they would go and you'd get that void in between the two magnets where there is no lines of magnetism. So that goes and shows what we need to know about lines of magnetism when thinking about magnetic fields.